right, welcome back, everyone. Today, we're jumping into one of the absolute classics in machine learning: regression, or more accurately, linear regression, as referred to in machine learning. This is the model that shows up everywhere, from predicting prices to estimating trends to making sense of how one thing affects another. Think of it as the training wheels of ML models: simple, steady, and super useful. And once you understand how it works, you will unlock intuition that carries over to many, many other algorithms. Let's start with a simple question. Can we teach a computer to guess the price of a car just from its mileage? Yes, we can. That's exactly the kind of problem linear regression can help us with. Imagine we collected a bunch of real car sales from our city. And for each car, we know how many miles it has and how much it was sold for. Every car gives us one example: mileage to selling price. If we plot all these cars on a graph, mileage on the bottom or x-axis and price on the side or y-axis, we get a cloud of little points. Each point is one car someone bought. Now, let's say you're helping a friend sell her car. She asks, "What do you think I can get for it?" You look at the mileage, suppose it has 43,000 miles. And now you want to give a smart estimate instead of guessing. One way to do that is to let your linear regression model draw a smooth line through all the sale points, and this line represents the general trend. Basically, cars with fewer miles cost more, and cars with more miles cost less. Using this line, you can trace upward from 43,000 miles, hit the model's line, and then trace horizontally to the price axis. Maybe it lands around $24,490. Boom, you've got a prediction. Now, why is this called supervised learning? Let's review this again. This type of learning is called supervised because we are literally supervising the model. We are giving it examples with the right answers. Each training example contains input, which is the mileage, and output, which is the selling price. Because the model has seen both the question and the correct answer for many cars, it learns the pattern. If the model is outputting a number like 24,490 or any other number like 1.7 minus 33, 420.5, we call it a regression problem. Linear regression is one model that solves regression problems, but there are others you will explore later. Besides the graph, naturally, another way to look at the data set is well as a table. Each row represents one car with a mileage and corresponding price. If you had 47 cars in the data set, you would see 47 rows in the table and 47 corresponding dots in the graph. Every row is one training example. You will see that term a lot. Let's talk about standard ML notation. But don't worry, this might seem a little bit confusing at this point, but it becomes natural as we progress. In machine learning, we use simple symbols so we can talk precisely. X is always our input feature. Here, in our example, the mileage. Y is the target value. In our example, the price. A pair of X and Y gives us one training example. If we number the rows, X1, Y1 is the first car, X2, Y2 is the second car, all the way to XM, YM for the mth car. Here, M denotes the total number of training examples. The superscript is not a power. You need to be careful. It's simply an index. In other words, x to the power of 2 is a square of x. But in our case, that's not what we mean. We just mean second example. X2 is our second example. X3 is our third example, and so on. Now, your client's car with 43,000 miles hasn't been sold yet. We don't know the price for it. That's why we train the model first using the known examples, and then we use the trained model to predict new cars it has never seen before. This is the heart of supervised learning. It means train, learn patterns, and make predictions. So in this lesson, you saw what supervised learning looks like, how linear regression tries to fit a trend, how inputs or X's and outputs Y's are represented, how training examples are organized, and how we use the trained model to make predictions. In the next lesson, we will take this same data set and walk through how the learning algorithm actually figures out the best line to draw. Trust me, once you see how the model learns, the magic of machine learning starts to click. See you there.